Good afternoon, good day, and welcome to my channel. I'm the Dr. Nadanios, and today I have a very nice information that I would like to share with you. This topic that even when I was a student in high school, people find very difficult to understand. That's a topic that today I would like to talk about and explain for people to get an understanding about it, get to know how the topic looks like. The topic that I would like to talk about today is latent heat. Latent heat. We talk about the latent heat. We talk about something which is hidden. It's something that people don't know. That's when you talk about latent heat. It's about latent heat. We talk about latent heat of latent heat of latent heat of vaporization. For example, we talk about latent heat of vaporization. For example, we talk about the amount of heat that absorbed or amount of heat absorbed or released when amount of heat absorbed when a liquid change from liquid state to a gaseous state without changing temperature. I hope everybody understand that point. Amount of heat released or absorbed by a substance or thermodynamic system without changing temperature. I hope everybody understand that. Let's look on the board and look at a small sketch that I would like to show you. Let's see that this is our bowl. Let's see this is our bowl that we are boiling. And what it? We have water for this. This is our boiling water. This is our tent. Tripod stand. We have heat. We've been supplied this with heat. And then this is our boiling water. Boiling water. So when it reaches a temperature in which is 100 degrees Celsius, 100 degrees Celsius, the water will start to boil. At this temperature, 100 degrees Celsius. When it reaches this temperature, 100 degrees Celsius, there's no going to be any change in temperature. I hope you should know. There's not going to be any change in temperature because when water boils at that boiling point, which is 100 degrees Celsius, temperature will not change again. For instance, there's no change to be 101. No, it will remain at 100 degrees Celsius. But at that 100 degrees Celsius, still there's supply of heat to the system. So this is the heat that we are talking about. This is the heat that we are talking about. Everybody should know. The heat that we're talking about here is the heat which is being supplied to this system at this temperature. And that's what you call latent heat. I hope you understand me. So at that temperature, 100 degrees Celsius, whereby the water is still boiling and changing to vapor state, is called latent heat. So without changing the temperature, everybody has seen that. So we will define latent heat of vaporization For example, here as amount of heat released or absorbed when a liquid change of state to a gaseous state without changing temperature. The emphasis is on without changing temperature. That's what we should know. The emphasis is on without changing temperature. The emphasis is on without changing temperature. So that's the emphasis that we are emphasizing here. So yeah, we can define latent heat as this. We write this formula equals to heat, Q representing heat over mass. I hope everybody knows this kind of formula. If you are confused, don't be confused. If you want to define heat, you know that define heat, which is Q, equals to MC theta. Excuse me, let me write this so that we can have a clear idea of what I'm talking about. So heat can be defined as Q equals to MC theta. However, we know that this is the y by m equals to the mass, C equals to specific heat capacity, theta equals to change in temperature, change in temperature. Okay, we know that. So with this, we have mass, we have a specific capacity, and a change in temperature. When you have latent heat, there's no change in temperature. That's why you have the heat that was supplied to it in the mass. That's what we have. And then we have different types of latent heat. We have different types of latent heat. Let's see how we can go about it. Different types of latent heat. So we have latent heat of vaporization. And then we have latent, so this one, we have latent heat of fusion. So when you talk about it, you look at it, latent heat of vaporization, that's the first one that we will already talk about. Latent heat of vaporization, amount of heat released or absorbed. I hope everybody is writing down. Amount of heat released or absorbed. Amount of heat released or absorbed by a substance or a thermodynamic system without changing temperature. Without changing temperature. I hope everybody has written down that. And then when we come to latent heat of vaporization, to amount of heat, when we come to latent heat of fusion, amount of heat required to change a liquid to a solid substance, which is ice. Here we talk about ice. To a solid substance without change in temperature. Without changing temperature. I hope everybody have gotten that. Apart from that, we have specific latent heat. When we talk about specific latent heat, everybody knows. I hope before you talk about the specific latent heat, you're supposed to know what is specific heat capacity is about. Yeah, specific heat. Everybody should know what is the specific heat capacity is about. So, when you talk about the specific heat capacity, we talk about amount of heat that's required to change one substance from one state to the other to require to change 1 kg of a substance. Amount required to change amount of heat required to change 1 kg of a substance. So when you talk about specific latent heat, we talk about amount of heat released or absorbed. Amount of heat released or absorbed by a substance. Amount of heat absorbed. Amount of heat released or absorbed by 1 kg. That's the emphasis. Specific. Yeah, we are emphasizing on a point. Specific. Amount of heat released or absorbed by 1 kg. By 1 kg of a substance without changing temperature. So, specific latent heat of fusion. Here we talk about amount of heat released or absorbed to change 1 kg of a liquid to a solid state. Here we're talking about ice. To a solid state without changing temperature. I repeat, specific latent heat of ice or specific latent heat of fusion. Here we talk about amount of heat energy released by a substance, amount of heat energy released by 1 kg of a substance, or in a thermodynamic system to change from a solid state to change from yes, it can be a solid state. It's change from a solid state to a liquid state without changing temperature, or to change from a liquid state to a solid state without changing temperature. I hope I've really helped you to make your understanding clear. If you have any question, you can write it down and I will answer you on my YouTube page. You can also subscribe to my page, Natadan on YouTube. So let's conclude what we were talking about. Latent heat of fusion. That's what we were talking about of light. That is the amount of heat released or absorbed by a liquid or a solid to change from one state to the other without changing temperature. Emphasis: without changing temperature. Without changing temperature. I hope everybody has gotten me right. Emphasis: here we emphasize on without changing temperature. Emphasis is on without changing temperature. So supposed to get conversant with that so that you can do so many things. Thank you very much for paying attention to me. I think I can attend to you at some other time again in case you have any other question, and you can also recommend some of the topics in science and medicine that you don't understand so that I can explain it to you. Thank you very much, and bye bye. If you need more explanation, don't hesitate, please. I repeat, don't hesitate to contact me on my page. I'm here for you. I'm here for everyone. I'm here to make things very easier for people. Things are not easy for people. I know learning science has not been easy in everybody's life. Don't think it's easy. It has not been easy. But from time to time, when you practice, that gives you that edge over the subject. You overcome it. You overcome everything about it. So, supposed to work out. That's why I urge you, don't be discouraged. Don't ever be discouraged. You can do it. You can do it. I know. So, without much aside, I would like to bid you bye-bye to this page and go. If you really want to understand the topic, you can go to the page repeat after one the other, repeat and repeat over, and then you'll be able to understand the topic well. And don't hesitate to contact me too. It's bye bye.